All right, for the next few weeks and the rest of the semester, we will be focusing on right triangles. So with a right triangle, that means that you have a triangle with one 90-degree angle. The side length that's opposite the 90-degree angle is called the hypotenuse, which, when we were doing proofs with congruence, we would call this H, and then one of the sides would be L. In this case, we're going to talk about the legs as being A and B, and the hypotenuse always as C. And the lengths of the legs always have this relationship that the sum of the squares, so A squared plus B squared, is going to equal the hypotenuse squared. So we said A, B, and C were the sides of a right triangle, a right triangle. The legs of a right triangle, so those are the sides that touch the right angle. And here's the most important thing, is that the legs have to be A and B in the formula, right? The hypotenuse is always C. So it's on the opposite side from the right angle, and it would be C in the formula. So we use the Pythagorean theorem when we know the lengths of two sides of a right triangle, and you want to find the length of the third. Whether or not it's a leg or a hypotenuse, you can figure that out. Okay. All right, so let's practice how this would work mathematically. So first of all, if you have on your calculator, you've got one of the yellow calculators or like the TI-30X calculator, you can often push that square root button and it'll show up on the display, and then you can like put a number under it, equals, and it will give you the square root. Now, if you have one of the little calculators that just doesn't have any of the fancy display, sometimes you have to write the number first, and then you push the square root button, and then it will tell you the answer. So it just depends on what kind of calculator you have. Small calculator. Okay, so here's how we would do it. Let's say we have triangle 1, A, B, and C. We're trying to find B. And C, we know, is always the hypotenuse. So when we set up the equation, we're going to say that A squared, so 6 squared, plus B squared equals 10 squared for C. So let's go ahead, and again, we're going to use that squared button. So if you see this button, you can push, say, 6, and then X squared button will make there be a little 2 up top. And when you push equals, it will give you 36. So that would be 36 plus B squared equals 100. And so now we're going to solve for B by subtracting the 36 from both sides, getting B squared all by itself, and then 100 minus 36 is 64. So now here's our last step, which is if we're trying to get rid of a squared, you have to do the opposite, which is find the square root. So if we take the square root of B squared and the square root of 64, like we talked about up here, you are going to get 8 as the answer, 8. So that's one where you have like a leg missing. So let's say here I have the hypotenuse is missing. So let me clear this out for a moment, just to give us a little bit of space. All right, so here we have A squared, so 5 squared plus 12 squared equals C squared. We'll evaluate each of these, so 5 squared will give you 25, plus 12 squared, which is 144, equals C squared. And so this is the easier one, because now all I have to do is add them, get 169, and now I take the square root of both sides and get 13. And that will be my answer. All right, so you guys, I want you to try to do question 3 here. If we're looking for A, how would we set up this equation? So go ahead and pause and work on that. All right, so let's see how that went. If we're going to look for a, we'll do a squared plus 24 squared equals 25 squared. A squared equals 5, oops, sorry, not equals, plus, let's erase that. 576 equals 625. We'll subtract. A squared is 49, and the square root of 49 is 7. And there we go. So another side note is that you can use the Pythagorean theorem when you have all three side lengths and you want to check if the triangle is a right triangle. This is called the converse of the Pythagorean theorem, which just means like backwards. So basically you take like the statement you had up at the top that if a triangle is a right triangle, then the formula will be true. And we are just going to switch the if and the then and say if the formula a squared plus b squared equals c squared is true, then it is a right triangle, and that would be a proof. All right, so we will test that in a minute, but let's just remember that there are a few, see how these were all really nice whole numbers? That's like, these are all good examples. So this is a good example, and here's another one, and we'll try to find another over here. But that are nice whole numbers that will give you a nice right triangle. And that doesn't always happen, right? Like if you have 3, 4, and 5, that's called a Pythagorean triple. Which is when you have 3 nice whole numbers that satisfy 3 squared plus 4 squared. Does that equal 5 squared? And it does. So you'll get 25 when you add them together equals 25. And so that should also be true for the last one. And why don't you try to do some of these and figure out which of these 3 is a nice Pythagorean triple, which one? So go ahead and pause and figure that out. All right, we're going to set this up. So this one should not be. This one will be. And if we were to do these, we'll do 6 squared plus 7 squared. And I would really recommend you practice this just so you get used to using the buttons on your calculator. Okay, so when we add those together, we end up getting 85, which is not 8 squared, because 8 squared is 64. So this is going to not be one. When you add these together, you get 225, which in fact is 15 squared. So that's pretty good. And this is another no-go. When you add these together, you get 850, which is not 30 squared. Okay, so on the back, we're going to work on a proof just to talk about like how you can think about this as areas. So just real quickly, we can prove that the Pythagorean theorem works using a geometric model. So this is just a picture. We've got a right triangle here, and we have 3 sides to it. And then what we did is kind of created a nice square on each of the sides. So like if we were to say that this is our 3, 4, 5 right triangle, 3, 4, 5. And if we were to figure out what the square areas would be, areas of each square, let's go ahead and do that. So the area of a square is just the side times itself, right? If you have a square with side 3, the other side is also 3. And so if you were to go ahead and fill in that 3, 4, 5, and multiply 3 times 3, you would get an area of 9, which is a squared. All right, my medium square is going to be 4 times 4, 4 squared, which is 16. And the area of this large square is 5 times 5, which is 25. And this is a great demonstration of it, because if we were to add the area of the small square plus the area of the medium square, we would get 25 square inches, which is exactly the same as the area of the large square. So that is our proof using figures that the Pythagorean theorem is in fact true. All right, so the rest of your assignment is going to be finishing these problems, finding the missing side lengths, and determining whether or not the sets of numbers are right triangles. And when you're done with this, you can turn it in and finish if you have any more ALEKS to do. And I hope you guys have a wonderful Thanksgiving. I'm sorry I'm not there right now, but I love each and every one of you, and I hope you have a fantastic holiday. Have a good one. Bye-bye.